To find the distance between 2 points, we're going to use Pythagoras' theorem. To use Pythagoras' theorem, we need a right-angled triangle. So on my diagram here, we can see I've got the point A, which is x-coordinate of 1, y-coordinate of 1, and the point B, which is the point 4, 3. And I want to find the distance between these. To create a right-angled triangle, I add in two lines that are parallel to the axis. So I'm going to go horizontally until I line up straight under B. Then I'm going to go vertically straight up there. And that creates a right-angled triangle. Now, to use Pythagoras' theorem, I need to know how long these sides are. I can count how far across I have travelled here. So I've started above the 1 and I've gone across 1, 2, 3 to the number 4. So I've gone up 3, so this is 3 units. From here, I've started across from the 1 on the y-axis and I've gone up to the 3 on the y-axis. So I've gone up by 2. Once I have these, then I can use Pythagoras' theorem. Remember, Pythagoras' theorem is c squared equals a squared plus b squared, where c is the hypotenuse, which is the long side, the longest side, which is opposite the right angle. So for this question, my missing distance here, which I'm going to call d for distance, so d squared is going to equal a squared plus b squared. So it's going to be 3 squared plus 2 squared. So 3 squared is 9 plus 2 squared is 4, giving me a total of 13. So the distance squared is 13. To find the distance, I would need to square root 13. Now, leaving it written as square root 13 is known as the exact answer, or a surd. But if I wanted to know what it was as a decimal, I would need to grab myself a calculator and type in the square root of 13, which gives me to 1 decimal place, 3.6. Now, there's no units on here. We normally write centimetres or metres, so we could write units if we wished. All right, let's look at another example. Say I've got another point. Let's pick this one here. We'll call this C. This is 2 back along the x-axis. Remember, always writing x first, so that will give me minus 2. My y value is 2. I've gone up 2, so it's the point minus 2, 2. This point over here, for example, let's call that one D. My x value is 1, and my y value is minus 2. So I want to find this distance now from C to D. So to use Pythagoras' theorem, I need to create a right-angled triangle. So I'm going to go straight down here, parallel to the y-axis, going straight down. Then I'm going to go straight across, parallel to the x-axis, creating a right-angled triangle. So I need to know their short sides. This distance here, I've gone from being in line with the -2 on the x-axis to being in line with the 1. So I've travelled across 1, 2, 3 units. So that's a distance of 3. This way, I've gone from in line with the -2 all the way up to the +2. So I've gone up 1, 2, 3, 4 units. So I have my short sides, so I find my long side using Pythagoras' theorem. So we're calling it D again for distance. So the distance squared will equal 4 squared plus 3 squared. So 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So the distance squared is 25. Remember to square root to get the distance. The square root of 25 is quite nice. It's the exact answer of 5 units. Okay, can we do this without drawing a diagram? Yes, we can, but it's a little bit trickier. So let's try an example where I don't have a picture. So if I gave you the 2 points, so if I call them, I don't know, let's call them point E. Point E we're going to make as, let's say, 2, 7. Let's make point F the point 8 and 15. Okay, so we need to try and figure out how to use Pythagoras' theorem without actually drawing the triangle. So we need to work out how far apart, so without drawing the triangle, we need to work out how far we've gone across and how far we've gone up to the second point. So to go across, I'm going to look at my x value. So I've started at 2 and I've gone across to 8. So I've gone across by 6 spaces. So that distance is 6. Here I've gone from 7, the y value has gone from 7 to 15. So from 7 to 15, I've gone up 8. So my short sides are 6 and 8. So to find the distance, it will be 6 squared plus 8 squared. Now if you grab a calculator, you could work that out. So 6 squared is 36, 8 squared is 64. Add them together, you get 100. So my distance squared is 100. Remember, I need to square root that to find the actual distance, which quite nicely works out to be 10 units. So without the diagram, it's a bit trickier. So we're working out the change in the x value for the first short side and the change in the y value for the second short side, and then putting them in Pythagoras' theorem to find the answer.